Well, some of them, the granite in the Great Pyramid comes from more than 500 miles to the south. If you look at the famous King's Chamber, its walls and its roof are, the ceiling of the King's Chamber are all made with gigantic granite blocks.
How did ancient Egyptians carve massive granite blocks with such astonishing precision, using tools supposedly too primitive for the job?
And then, so this is where people say, well, this groove could have been made when they retracted the tool, like it unscrewed itself.
For centuries, experts insisted copper and sand were enough, yet the evidence tells a very different story, one of hidden technology and impossible engineering feats.
All right, we have a big block of granite here. So how's this copper going to cut this granite? We're going to use the saw.
Imagine discovering a toolmark that defies everything we thought possible, etched into granite with the precision of modern machines.
And yeah, so and then when you compare that to our modern tools, that's it essentially penetration rate into stone than we can achieve.
What if this discovery could rewrite history and prove our ancestors wielded knowledge and power far beyond what textbooks admit? That's exactly what we're about to explore. The copper and sand paradox. For more than a century, textbooks and universities have offered a tidy explanation for how the ancient Egyptians carved granite, copper tools, and sand. According to this accepted theory, copper chisels and saws, combined with abrasive desert sand, were manually rubbed against stone surfaces to grind and cut. Quartz sand's hardness supposedly made up for copper's softness by acting as the cutting agent, worn down grain by grain over thousands of hours. On paper, it sounds reasonable. Time and effort can achieve a lot, but when we apply modern mechanical engineering principles, serious contradictions emerge. Abrasion with loose particles like sand is inherently chaotic at the microscopic level. Sand grains tumble, slide, and collide unpredictably between the tool and stone, producing random impacts that create rough, scratched surfaces. Anyone who's sanded wood or stone knows the result isn't smooth or flat. Instead, it's a matte finish covered in overlapping scratches going in all directions. This kind of random friction couldn't form the razor-sharp cuts seen on Egyptian granite artifacts. The physical evidence from Egyptian sites challenges the copper and sand narrative directly. Granite objects found at places like the Serapeum in Saqqara and statues within Luxor's temples exhibit mirror-smooth surfaces, their flatness and shine comparable to glass. Even more astounding are the interior right angles of massive granite boxes, weighing hundreds of tons, which appear so sharply defined that one might mistake them for glass panels assembled with surgical precision, not carved from stone. A manual process relying on human effort to rub loose sand inevitably rounds edges, due to uneven force application, making it impossible to achieve those crisp right angles. What's required, physically and mechanically, is a tool that imposes a fixed directional cut.
That is that the specific nature of the tool marks, the striations and cuts that we can observe on ancient basalt and granite.
Something stable and precise, rather than a chaotic, free-moving mass of abrasive grains. This fundamental contradiction reveals a paradox. The accepted method would leave rough, uneven surfaces, yet the granite shows clear evidence of deliberate, controlled cutting. Material science confirms that the character of a cut directly reflects the nature of the cutting tool. Dull or loose blades produce ragged, inconsistent marks, while stable, sharp edges leave smooth and exact cuts. The granite blocks of ancient Egypt bear no mark of random abrasion. They display the signature of intelligent, steady control, a clue pointing to technology far beyond simple copper tools and sand. Examining the polished external surfaces alone isn't enough to understand this mastery. True proof lies beneath, within the deeper cores of the stone removed during cutting, unseen portions that ancient craftsmen left behind, assuming no one would examine them. These hidden details hold the key to unraveling the mystery of the pyramid's construction. The accepted story of copper and sand deserves scrutiny, because it cannot explain the exceptional precision witnessed in Egypt's granite monuments. This paradox sets the stage for what lies hidden in the core drill artifacts discovered over a century ago, evidence that defies conventional explanation and points to a lost chapter in technological history. The answer to this puzzle is etched deep within core drill number 7.
Petrie, and it's called Petrie's core number 7 because Flinders Petrie discovered it,
Right.
and it's exhibit number 7
Right.
on his. And this is the one that's been studied.
A small but extraordinary artifact unearthed in the sands of Egypt. Evidence from core drill number 7. In the late 19th century, Sir William Flinders Petrie, often called the father of modern archaeology, undertook a meticulous survey of the Giza Plateau. Unlike many explorers chasing treasure or tombs, Petrie focused on engineering precision, collecting everyday discarded remnants from pyramid construction. Among his collection were tubular stone cores left from drilling, long hollow stone cylinders protruding from granite blocks. To most, these fragments were waste. To Petrie, they were invaluable data points. One of the most remarkable finds was core drill number 7, a red granite cylinder, with a feature that completely shattered assumptions about ancient technology. Instead of displaying random scratches expected from loose sand abrasion, it bore a continuous spiral groove winding smoothly from top to bottom, resembling the thread of a modern screw. This uninterrupted spiral is a hallmark of highly controlled, mechanical cutting. This groove, precisely etched and unbroken, indicates far more than rotational motion. It reveals a cutting mechanism fixed in place, applying a steady, powerful force with exact geometric control. Such a feature is impossible if sand grains were randomly tumbling inside a copper tube, as the chaotic movement would erase all spiral patterns. Instead, only faint concentric circles or crude vertical scratches should appear, never a seamless and deep spiral groove like this. Mechanical engineers recognize this as the signature of turning or controlled cutting. To carve a spiral groove into hard granite, the cutting point must remain immobile, relative to the drill bit, and be tough enough to maintain its path under intense pressure. Imagine a plow slicing soil. The furrow it leaves is precise because the plow blade is rigid and pushed forcefully. Core drill number 7 shows the same principle, but cutting through quartz crystals rather than earth. This evidence dismisses loose sand as the cutting agent and demands a fixed, hard cutting edge delivered with substantial force. The copper and sand model cannot produce the spiral definition etched into this granite core. Instead, it points to an industrial-like machining process, one that ancient manual labor simply couldn't replicate. More strikingly, engineers measuring the drill's spiral groove spacing, the feed rate, discovered numbers shocking by today's standards. The drill advanced approximately 2.5 millimeters with every full rotation, a rate far exceeding what modern diamond drill technology achieves at thousands of revolutions per minute. Ancient operators apparently employed much slower rotation speeds, but immense downward force to plow through granite. It signals the existence of an unknown, advanced mechanical culture that engineered granite with a sophistication beyond our accepted historical narrative. The impossibility of manual pressure. The extraordinary feed rate and spiral groove depth on core drill number 7 demand forces no human worker could sustain, and a tool no copper blade could withstand. Copper softens and deforms under even modest pressure compared to granite's toughness, meaning any copper tube under 2 tons of axial force would buckle or crumple before carving a single groove. The reality of material science lays bare this physical impossibility. Furthermore, sand grains under such concentrated pressure would collapse into powder, losing their abrasive utility. Sand only works when grains remain intact and rolling. Compressed beyond a threshold, they turn into a cushion, preventing effective cutting. This deepens the paradox. The very abrasive agent presumed critical in traditional theory ceases to function under required drilling pressures. Human muscle simply cannot generate or maintain the sustained force and perfect mechanical stability to drive a drill bit deep into granite at 2.5 millimeters per revolution. Applying 2 tons of steady pressure Rotating the drill and maintaining perfect vertical alignment simultaneously defies biological limits. The necessary precision is beyond nerve control, muscle fatigue, and bodily tremors, all of which introduce unavoidable wobble in hand-guided tools. Yet, core drill number 7 and hundreds of other drill holes found at ancient sites boast perfect roundness, straight axial alignment, and uninterrupted spiral grooves. Such geometric perfection cannot be the product of human operation alone, indicating complete removal of manual variability. The tool must have been mounted in a rigid frame with a fixed rotation axis, powered by a drive system converting energy into smooth, consistent motion, essentially a machine. This mechanical fixturing concept is fundamental in modern precision machining, but finds no direct archaeological evidence at the sites, likely because such frames were made of perishable materials like wood, recycled over centuries. Nonetheless, the artifacts themselves serve as forensic evidence, the bullet proving the existence of the gun. Core drill number 7 carries the unmistakable signature of a rifled barrel-like machine, a lost legacy of ancient engineering. These revelations demand a reassessment of the ancients' technological sophistication. The image of laborers hacking stone with primitively simple tools no longer holds up. Instead, it suggests an advanced culture of machinists, skilled in applying high energy to transform incredibly hard materials with surprising ease and control. The wonder deepens as we move from the microscopic evidence of the drill core to larger artifacts that challenge assumptions about hand craftsmanship and hint at a full spectrum of forgotten engineering marvels. The microscopic mystery of granite cuts. Looking closer at core drill number 7 reveals a puzzle that defies traditional craftsmanship. Granite isn't uniform. It's a crystallized magma composed of minerals like feldspar, mica, and quartz, each with different hardness levels. Normally, when abrasive tools grind stone, the softer minerals erode faster, leaving a rough, uneven surface. Harder quartz crystals resist wear or become plucked from the matrix, creating jagged pits. This is precisely what you'd expect if copper and sand were doing the work. Yet, microscopic examination of the spiral groove on core drill number 7 tells a very different story.
Alright, I'm sure you know there are carbide coring bits and diamond core bits. I'm Nick from Ohio Power Tool. Let's talk about carbide and diamond core bits.
The groove cuts through feldspar and quartz with eerie smoothness and uniform depth, ignoring the usual hardness differences. No pits, no recesses, no plucked crystals mar the surface, just a clean, precise cut through the entire mineral matrix. This consistency defies all known cold abrasive processes and begs the question, how was it done? Even more astounding is what happens to the quartz crystals along the cut path. Instead of fracturing along their natural cleavage planes, a hallmark of brittle failure, they appear sliced or plastically deformed. Quartz, a brittle material under normal conditions, shouldn't behave this way. For crystals to be plastically deformed without shattering, extreme heat and pressure are required, conditions unheard of in ancient manual stoneworking. This phenomenon, known as localized plastic deformation, means that momentarily the granite didn't act like hard rock, but more like soft wax or pliable plastic. Modern machining achieves this with ultra-high-speed tools or intense heat sources, generating frictional energy sufficient to melt the stone locally at the cutting zone. The material softens only long enough for the tool to pass, then cools and re-hardens. This explains how such flawless grooves could form. The implications are profound. The tool that made core drill number 7 was not just harder than granite. It was a high-energy instrument capable of transforming matter itself rather than chipping or grinding it away. The traditional image of copper chisels and wet sand falling short here isn't conjecture. It's contradicted by clear, microscopic evidence. Sand and water act as coolants in manual processes, preventing temperature rises essential for this kind of deformation. This forces a re-evaluation of accepted history. The familiar story of slaves laboring to chisel stone with primitive means no longer fits the data. Something far more advanced, clearly existed, a technology able to manipulate the physical state of hard stone in ways modern engineers have only recently begun to replicate. It's a mysterious chapter of human ingenuity hidden beneath layers of forgotten time. But possessing such a high-energy cutting tool raises another vital question. If it wasn't just the hardness of a blade, but also the steady control of its movement that mattered, how was this precision achieved? A sharp tool, held by an unsteady hand, simply could not create perfect spirals across granite's tough surface. The answer lies in the remarkable stability and mechanical fixturing that must have guided the tool's motion, hinting at a lost ancient machine culture. This microscopic mystery prepares us to consider the broader context of that ancient mastery. The lost mechanical tradition. The precision and force evident in core drill number 7 cannot be fused with the slow, labor-intensive image of Bronze Age artisans pounding stone with copper. Instead, they speak of an ancient mechanical tradition possessed of machines capable of applying immense pressure and maintaining absolute geometric control. This tradition was likely grounded in principles of mechanical fixturing, rigid frames holding tools at fixed angles, combined with power sources converting energy into consistent, smooth, rotary motion. Though no direct archaeological remains of such machines survive, probably due to their likely wooden or organic construction, later dismantled or rotted, the stone cores themselves attest to their existence. Just as a bullet's rifling marks prove the presence of a rifled barrel gun, even if the firearm is lost, the spiral groove on core drill number 7 guarantees the prior presence of a machine. These ghost machines challenge the mainstream narrative and demand a rewrite of ancient history. The ancient Egyptians were not merely monumental builders, they were skilled machinists who understood materials, science, and engineering principles well ahead of their time. The craftsmanship recorded on these stones reflects knowledge of force, cutting dynamics, and precision measurement that only modern engineering has recently rediscovered and refined. They had tools delivering colossal force combined with perfect control, an industrial process hidden in plain sight. Such technology would explain how thousands of granite blocks, weighing tons each, were cut and shaped with such exacting detail and consistency. The faint mechanical traces in the stone reveal a lost era of technological peak, erased by time but still echoing through artifacts and monuments. This lost mechanical tradition extends far beyond a simple tool. It speaks to a culture advanced in mechanics, energy control, and precision engineering. Skeptics may argue this technology was accidental or limited, but mounting evidence suggests otherwise. The geometric perfection of the drill cores, alongside complementary artifacts, shows a level of refined and repeatable process rather than chance. These craftsmen operated with frameworks and machines designed to eliminate human error, producing consistent, flawless results invisible to casual observation. This discovery forces us to reconsider the entire trajectory of technological progress. The ancients attained a peak of machining ability that rivals modern standards, yet inexplicably vanished, leaving humanity to relearn what was once known. Questions abound. Why did this knowledge disappear? What caused the loss of such precision and power? And what else might lie hidden beneath the ruins and rubble? The lost mechanical tradition invites us into an extraordinary dialogue with our past, a conversation that challenges the linear view of progress. It reveals history as fractured, with peaks of technology lost and rediscovered, reminding us that human achievement is often a story of rises and falls, not steady advancement. Together, the core drill and the Sabu disc sketch a world that defies expectations, urging us to look beyond assumptions and recognize the astonishing realities that crafted one of history's greatest civilizations. The Sabu disc and advanced engineering. Among the most striking pieces of evidence supporting an advanced ancient mechanical tradition is the Sabu disc, discovered in 1936 near Saqqara and dating to approximately 3000 BCE. Crafted from schist, a metamorphic stone known for being extremely brittle and prone to shattering, The disc defies conventional explanations of prehistoric workmanship. Any attempt to carve such delicate, thin, and intricately curved elements with simple tools would almost certainly have fractured or destroyed the artifact. Yet this disc remains perfectly intact, hinting at extraordinary skill and technology. The disc measures roughly 61 centimeters in diameter and features a hollow central hub with 3 gracefully curved inner spokes flowing seamlessly like silk ribbon. Its rims taper to impossibly thin edges that challenge the limits of hand-carved stonework. From a manufacturing perspective, its complex geometry is the opposite of what novice stone carving would produce, requiring instead techniques that remove material gently and precisely, methods akin to lathe turning or progressive abrasive machining. Archaeologists have often labeled the Sabu disc a bowl or ceremonial lamp, but these interpretations fail under scrutiny. The wide gaps between the spokes would spill any liquid it holds, making it a poor vessel. Its design also obstructs light, making it ineffective as a lamp. To modern engineers, the disc resembles a mechanical component, a flywheel or centrifugal impeller used in pumps. The curved spokes reveal aerodynamic properties clearly engineered to interact with fluids or gases during rapid rotation. This suggests the Sabu disc was not a mere ornamental object, but part of a functional device designed to handle mechanical stress and precise movement. Such sophistication implies that the designers understood principles of centrifugal force, fluid dynamics, and rotational balance, concepts far beyond simple carving and artistic decoration. It is a signature of skilled engineering embedded in stone, speaking volumes about the culture that produced it. The disc's physical nature aligns perfectly with the insights gained from core drill number 7, where the drill proves the capability to cut intensely hard materials with immense force and control. The disc reveals a mastery of brittle materials shaped with delicate precision. Both artifacts demand an advanced degree of control over matter unseen in other ancient contexts, underscoring a vanished culture of high mechanical knowledge. These pieces together paint a fascinating picture, a civilization that transcended mere monument building, one that wielded mechanical tools and concepts we typically associate with modern industry. It challenges the long-standing assumption that such technical sophistication was impossible before the modern era. Instead, it suggests ancient Egyptians may have pioneered a highly developed technology that disappeared due to obscurity or cultural decline. What's particularly remarkable is that neither the drill cores nor the Sabu disc suggests random trial and error or crude experimentation. They reflect calculated design, mechanical precision, and engineering thought, hallmarks of a culture deeply engaged with physics and material science. This demands we reconsider the narrative of human technological progress as a smooth, linear path and acknowledge lost chapters of human capability. The incredible precision and engineering of ancient Egyptian granite cutting challenge everything we thought we knew about history and technology. The evidence from core drill number 7 and the Sabu disc reveals a lost world of skill and innovation far beyond simple tools. If this journey into ancient ingenuity fascinated you, please like this video, subscribe for more, and share your thoughts in the comments. Unlocking the past together starts with curiosity today.